On page 1 of today's worksheet packet, we are going to sketch the absolute value of each equation. We need to remember the generic y equals absolute value of x function is a V-shaped graph with its vertex at the origin opening upward. As we look at number 1, we can see that we have a negative in front of the absolute value symbols. This means it's going to flip upside down, and now instead of opening up, it's going to open down. We see the -1 inside the absolute value symbols. This means it's going to shift 1 to the right, and then we see the +1 outside of the absolute value symbols. So that means it's going to shift up 1. So we can start at the origin. The -1 tells us to go to the right 1. The +1 tells us to go up 1. So our vertex is going to be here at x equals 1, y equals 1. And the negative tells us this is going to open downward. So from that vertex, we can draw one side, draw the other side, and now we have our absolute value. Now let's look at number 2. The -3 tells us we're going to shift right 3, and then the -5 outside the absolute value function tells us to shift down 5. So this tells us to go right, this tells us to go down. So we're going to start at the origin. We're going to go right 3, down 5, and we're going to put our vertex point. Now we can draw it going up because there is not a minus sign in front of the absolute value symbols. So this one opens upward. And this is what the absolute value function on number 2 would look like. Number 3, we have x -3. This tells us to shift right 3. And then we have -4. That tells us to shift down 4. There's no negative in front of the absolute value symbol, so this tells us it opens upward. So we can start at the origin, go right 3, down 4, and plot the vertex point. Then it opens upward. Number 4. We have a negative in front of the absolute value symbol, so that tells us it opens downward. We have x -3 inside the absolute value symbol. That tells us to shift right 3. And we have +4 outside the absolute value. So that tells us to shift up 4. So we're going to start at the origin. We're going to shift right 3, up 4, and plot our vertex. And now this time the negative tells us to open downward. Number 5. We have x plus 1 inside the absolute value symbol. So this tells us to shift left 1. So we're going to start at the origin. We're going to go left 1, and we're going to plot our vertex. And then it's going to open upwards. Number 6. We have x minus 2 inside the absolute value symbols. So we shift right 2. We have minus 3 outside the absolute value symbol. So that tells us to shift down 3. So we start at the origin. We go right 2, down 3, and plot our vertex. And it opens upward. Number 7, we have a negative in front of the absolute value symbol. So that tells us this graph opens downward. We have x minus 3 inside the absolute value symbols. That tells us to shift right 3. And we have plus 5 outside the absolute value symbols. That tells us to shift up 5. So we start at the origin. We go right 3, up 5, and plot the vertex. And this one opens downward. So we draw the sides going down. And finally, on page 1, number 8, we have x inside the absolute value symbols. So we stay at the origin. Then we have plus 1 outside the absolute value symbols. So we shift up 1. So we're going to start at the origin, go up 1, and plot our vertex. And this opens upward. On page 2, we are going to write the equation from the graphed absolute value function. So this will always start out with y equals. Number 1 opens upward, so that's positive. Then we have absolute value of x, and we see that this shifted left 2, so we're going to put plus 2 inside the absolute value symbols. It does not shift up or down, so we don't subtract or add anything after the absolute value symbols. So the equation for number 1 is y equals the absolute value of x plus 2. For number 2, again, we start with y equals. This graph opens upward, so it's positive. Now we have absolute value of x. We see that it shifted left 1, so that's plus 1 inside the absolute value symbols. Then it does not shift up or down, so we do not add or subtract anything outside the absolute value symbols. So the equation for number 2 is y equals the absolute value of x plus 1. Number 3. We start with y equals. This graph opens downward, so we need a negative absolute value of x. We see that it shifted left 2, so that's plus 2 inside the absolute value symbols. And it did not shift up or down, so we do not add or subtract anything outside the absolute value symbols. So our equation for number 3 is y equals negative the absolute value of x plus 2. Number 4. We're going to start out the same way. Y equals. This graph opens downward, so we need a negative. Then absolute value of x. We can see the vertex is shifted left 3. So that means plus 3. Then we can see the vertex has been shifted up 4. So we need to add 4 after the absolute value symbols. So the function for number 4 is y equals negative absolute value of x plus 3 plus 4. Number 5. Y equals. This graph opens downward, so we have a negative absolute value of x. It has not shifted left or right, so we can close the absolute value symbol. But we see that it shifted up 1, so that is plus 1 outside the absolute value symbols. So the equation for number 5 is y equals negative the absolute value of x plus 1. Number 6. Y equals. This graph opens downward, so we have a negative absolute value of x. The vertex shifted left 4, so that's plus 4. Close the absolute value symbol. And it shifted up 2, so that's plus 2 outside the absolute value symbols. So the equation for number 6 is y equals negative the absolute value of x plus 4 plus 2. Number 7, y equals, this graph opens upward, so we have absolute value of x. It shifted left 1, so we add 1 to the x and close the absolute value symbols. And then the vertex shifted up 3, so that's plus 3 outside the absolute value symbols. So number 7 is y equals the absolute value of x plus 1 plus 3. And finally, on page number 2, number 8, we have y equals, the graph opens down, so we have negative, open the absolute value symbol, x, the vertex shifted 2 to the right, so that's minus 2, close the absolute value symbol, and the vertex shifted down 2, so that's minus 2 outside the absolute value symbol. So the equation for number 8 is y equals negative the absolute value of x minus 2 minus 2. On page 3, we are going to determine the domain and range of graphs. Remember, if we have a solid point, the number is included. If we have an empty point, it is not included. The domain refers to x, and the range refers to y. So in number 1, the lowest x is negative 3, and we have a solid point, so that is included. So we would put square bracket negative 3, comma, this highest x value is positive 2, and we have a solid point, so it is included, so that is a square bracket. So the domain is from negative 3 included to 2 included. The range refers to y. The lowest y value is negative 5 included. So square bracket negative 5. The highest y value is 5, and that is also a solid point, so square bracket. Number 2, domain is x, so our smallest x value is negative 1. In number 2, the lowest x value is negative 1, but we have an empty point there, so it's not included. So we have parenthesis negative 1. The largest x value is 3, and that's a solid point, so we have square bracket because it is included. Range, the lowest y value is negative 4, and that is a solid point, so it's included. And the largest y value is positive 4, but there is an empty point, so that is not included. For number 3, domain, our smallest x value is 1. That is a empty point, so it is not included. So 1 is less than x. And the largest x value is 4, and that is included. So we would say less than or equal to 4. So you can either write these like we did in number 1 and 2, or you can write these like I'm doing in number 3. For the range, my lowest y value is -4. That is an empty point, so it is only less than x, and that would be y. And then the largest y value is -1. There's a solid point, so it is included. We could say less than or equal to -1. So my domain refers to my x values. My range refers to my y values. So number 4, domain. My lowest x value is -5, and there's an empty point, so it is not included. My largest x value is 4 with a hollow point, so it is not included. My range, lowest value of y is 4, not included because there is an empty point. Highest value of y is 5. There's a hollow point, so it is not included. Number 5, our domain would be from -5, not included because of the empty point, until 0, not included because of the empty point. Our range would be -5, not included because of the empty point, until +5, not included because of the empty point. Number 6, the domain x starts at -5. It is included because of the solid point until 5, which is not included because of the empty point. Our range, y starts at -5, not included because of the empty point, and goes until y equals 5, included because of the solid point. Number 7, our domain starts at x equals -5, included because of the solid point, and goes until x equals 5, not included because of the empty point. The range starts at y equals -5, included because of the solid point, and goes until y equals 5, not included because of the empty point. And number 8, our domain starts at x equals 2, included because of the solid point, and goes until x equals 3, included because of the solid point. Our range starts at y equals 1, included because of the solid point, and goes until y equals 3, included because of the solid point. On page 4, we're going to continue finding the domain and range, but we're also going to write the function. So our domain on number 1 starts at x equals -2, not included because of the empty point, and ends at x equals +2, included because of the solid point. The range starts at y equals -4, not included because of the empty point, and ends at y equals 4, included because of the solid point. Our function we can write in function notation. So f of x equals our slope. If we start at the origin, we can see we go up 2 over 1 to get to the next point. So that means our slope is 2x. And then we would add or subtract the y-intercept, but we see that we cross the y-axis at 0, so we don't need to add or subtract a y-intercept. So our function is just f of x equals 2x. For number 2, the domain starts at x equals -3, not included because of the empty point, and it goes until x is 5, not included because of the empty point. Our range starts at y equals -5, not included because of the empty point, and goes until y equals 5, not included because of the empty point. Our function would be f of x equals our slope. In order to go from one good point to the next, I could use this beginning point, and I could use this point at our x-intercept. And this says we go down 5, right 4. So our slope would be -5 over 4x. And we see that we cross the y-axis at maybe 1.25. So when we write these, we can write these in slope-intercept form. Simply put your slope before your x, and then add or subtract where you cross the y-axis. Number 3. Our domain starts at x equals -4, not included because of the empty point, and it goes until x equals 1, included because of the solid point. The range starts at y equals -2, not included because of the empty point, and goes until y equals 1, included because of the solid point. Our function would be f of x equals our slope. We could say that we went up 3, right 5, so that would be 3 over 5x. And it looks like we cross the y-axis at maybe 0.4 or 0.5. So we would add 0.5. Again, 3 over 5 is our slope. 0.5 is our y-intercept. Number 4. The domain starts at x equals -1, not included because of the empty point, and it goes until x equals 3, not included because of the empty point. The range begins at y equals -5, not included because of the empty point, and goes until y equals 3, not included because of the empty point. Our function would be f of x equals our slope from beginning to end. We go up 8, right 4. So that would be 8 over 4 x. And it looks like we cross the y-axis at -3. We could simplify this. 8 divided by 4 is 2. So f of x equals 2x minus 3. Number 5. The domain starts at x equals -1, included because of the solid point, and goes until x equals 3, included because of the solid point. Our range starts at y equals -4, included because of the solid point, and goes until y equals +4, included because of the solid point. Our function would be f of x equals our slope. If we start at 4 and go down to -4, that's 8, -8. And we go over from -1 to 3, so we go over 4. We cross the y-axis at +2, so we add 2. We can simplify this because -8 divided by 4 is -2. So our function is f of x equals -2x plus 2. Number 6. Our domain starts at x equals -4, included because of the solid point. It ends at x equals 2, not included because of the hollow point. The range begins at y equals -4, included because of the solid point, and goes until y equals +5, not included because of the hollow point. Our function would be f of x equals, our slope from beginning to end goes up 9 over 6. And we cross the y-intercept at 2. We could simplify this. 9 over 6 is 3 over 2. So our function is f of x equals 3/2 x plus 2. Number 7. Our domain starts at x equals -5, included because of the solid point, and ends at x equals 1, included because of the solid point. Our range starts at y equals -5, included because of the solid point, and ends at y equals 1, included because of the solid point. Our function would be f of x equals, our slope goes down 6 over 6. And we cross the y-axis at -4. We can simplify this because -6 divided by 6 is -1. And our function is f of x equals -x minus 4. And number 8, the domain starts at x equals -5 and goes until x is 4. The -5 is included because of the solid point, and the 4 is not because of the empty point. Our range starts at y equals 4 and goes until y equals 5. The 4 is included because of the solid point. The 5 is not included because of the empty point. Our function, f of x equals, our slope goes up 1 over 9. And we cross the y-axis at what appears to be approximately 4.5. So our function would be f of x equals 1/9 x plus 4.5. Remember to study for your test on Monday. Bring your computers because the test is on Kiddo. If you need to review any of the material, please use the website to go back and re-watch our videos from the second half of Unit 4. That's lessons 10 through 18.